something which is different called as reinforcement learning that comes under the title. Right, so this is what my general agenda is, and please see that this is going to be an outcome. Once after completion of this session, please see that whether you have earned these three outcomes or not. Right, are you agreeing with me? And it is a prolonged session, so I don't want myself only to speak. I expect you people also to share some information so that we can have a duplex communication, not a simplex communication in terms of computer networks. Right? Okay? Now, so it is a 3-day program. So as you see that I don't want to touch up what is artificial intelligence, what is machine learning, these and all. I think so from the previous 2 days only you have completely undergone. Right, right, directly I will go into my business, today's business. Right, so these are all these agendas. So as I said that I will. So this is the. I have to appreciate this institution for conducting a seminar on AI, because that is really a wanted one. Right. So after the next, if you see the next few years, so you will be able to see everywhere AI is going to predominantly it is going to dominate. Nowhere, even in a petty shop, there are going to be an AI. So without AI, nothing is going to be there in future here. And initially, before 40-50 years back, they spoke about computers. So how the computer will lead the world. And now if you see, the petty shop also has a computer to make a small billing. In such a way, so the AI is going to be dominated. So knowing the right perspective, so this institution has given an approach to the state government, and they got a funding, and real appreciation to the team on the behalf of myself and my institution. So I congratulate and thank the institution and the head of the department who have been in charge for calling all these participants to share to get their expertise. Thank you, sir, first of all. And this is and the second thing what I said is that, so first of all we should know what actually an AI program is. So there could have been lot of definitions. They would have said what is AI? It is human being, human thinking. The computer should think like a human. Right? Whatever the definition it may be, first we should be able to understand, right, what actually the AI in terms of the program. Because we have to write a program. And now you should know, you should write a program, and I should say that this program contains an AI concept. For that purpose, there is a test called as Turing test. Any program you are writing, and all the program cannot be called as an AI program. And if I want to say that it is an AI program, it has to undergo a test called as Turing test. That was the person who introduced this concept. So after the Turing test only, I can say that the program what you have written it comes under the artificial intelligence, and it incorporates certain concept of the machine learning and all. Right? So the first very basic the AI algorithm is a linear regression model. And normally everyone could have said what actually the linear regression model is, but today we are going to write in a Python compiler, and you are going to see how this linear regression works. That's what I told, that is my first agenda. So you are going to work now. And everyone should have their mobile phones, and whatever the coding has been mentioned here, you have to write that, and you have to see that whether it is working. And if it is working, then you see that the today's day that you have run an artificial intelligence program. That should be a pride to you, because it is going to be a practical approach. And I will say you, even today if you are not able to do it, so I will share the PPT, so you can take the codings and you can work out and see. And any 2 or 3 students who are continuously working with this coding, then really that will be a good success of this program. That is the way which we analyze the outcome here. Next, I want to talk about just future AI technologies, as my title comes that related to the AI, I will tell what is what. See, for 1 hour, be very sure that I cannot tell all the AI technologies, because to understand the name itself, it will take 1 week to 2 weeks. Right. But I will say what are all the prevailing AI future technologies. Among that, I will tell what actually this reinforcement learning is, the advancement in reinforcement learning. And then, so the recent I told now, the Tamil Nadu government have implemented an AI. That I will show you how it has been and what it has been, and some advanced techniques and our programs. So this is how you have gone across for the past 2 days. So this is how you have started. So you have started with AI, and you have seen some knowledge, knowledge representation and all the other things. And inside the AI, you have been taught about what the machine learning is. So be very clear that machine learning is in what way we make ourselves learning. So how I learn, for example, if there is an animal, if I want to know what the animal is, someone has to teach us. So initially my parent have shown me a dog and said that it is a dog. And what I do is that for my understandability, so I will be able to connect it with a lot of parameters, saying that the dog eyes will be like this, the nose will be, there will be a tail. And if I see something different animal which is same like as a dog, so I will make a comparison, my image. So that is what I do here is that in my mind I store an image. The image has certain values. The image has certain pixels, in terms of the pixels. So I have remembered, or I have stored it. And whenever I see today a dog, if I want to say it as a dog, there should be some confirmations from my part. Right. So for that purpose, what we do is that instead of what your parent have done, what your environmental has done, that has been done with help of our ML. Machine learning. So it makes the computers to think. Right? So whatever the captcha, whatever we see here, no. So they will say where there is an eyes. So I have to point out the box. This is what the eyes is. So there will be squares, 16 squares, and I will ask that where is the ladder? Where is the signal? So all that 16 rows and columns, no, 16 cells. Among that, whatever you click will be referred as 1. Whatever you are not clicking will be referred as -1. I will make a comparison and I will say that whether you have selected it in a right or wrong. This is how the captcha, small captcha works. That is the basic AI concepts. Next, you are listening to a YouTube, you are listening a song. You usually used to listen melodious song. So whenever you type it, whenever you go to the YouTube, automatically it comes as a melodious song, because that is what the learning is. So your parent knows what you want to eat at morning, what you prefer at afternoon, what you prefer at dinner. That your parent knows. Accordingly, they will cook. The same thing I am doing here. I am making the machine to learn by giving n number of inputs. I give n number of inputs and I am making my computer machine to learn. That is what in terms of ML you are did it. So all this linear logistic regression, k-means, support vector, these are all the algorithms. Be very clear. The algorithms, there are n number of algorithms. We have to know what algorithm we have to select. A simple logic which you have to understand is that first you have to throw out a myth. Normally everyone has that AI. If you think AI, you don't think that it's a very big program. I have to write 1,000 lines of coding for AI. No. If you see the linear regression program, it is only a 10 to 15 line program. That too in C program, we have written several codings to add 2 numbers. But in Python, it is only 1 or 2 lines. So whenever the technology comes, whenever the technology emerges, you see that you are given a very simple concepts. So Python is very simple. Comparing to the R programming, you take R programming, again it is very simple. And you can ask me, how can you say that it is very simple? Because It is all available, we have to select and use it. I will assure you, see that if you work with an online tool, everything is available. Initially, I have to write a HTML code in a notepad. So right, for HTML, I have to write 100 lines coding. Now it is not, now that is not required. In a single click, everything is available. Use it. You need not again go start from the tag and you need not end it. So likewise, see, these are all the algorithms. You need not make any confusions. The algorithms are like a different people. See, there are 10 members, right? They are going for an hospital. All the 10 members are suffering from fever, and the doctor gives the same capsules to the different people. So one will be get cured in 1 day, the other will get cured in another 2 days, one will get cured for another 1 week. So the capsule is same, the fever is same, but recovery will differ based on the individual person's body. That is what the algorithm is. So we have different algorithms. Each and every algorithm work with a different perspective. It is so it is applicable for the different person. For example, you take the bus. It is used to transport, and train. It is also for a transportation. If you go for a flight, it is also a transportation. But see, in what way everything is a transportation, but the sophistication, the quality of parameters, it differs. For each and every transportation, it differs. That is what. Don't confuse with this algorithm. You need not study all these algorithms and all. Because of that itself, everyone are not entering to the AI. They are all thinking that, so reading, how can I read this K-means algorithm? You need not read. You need not learn anything from K-means algorithm. You call the K-means algorithm in Python, the Python will do. Right? Just think, the thing is that you should know what tool you have to use. Right? Nowadays, so how the yesterday's session you could have seen, your doctor's role has been very minimized. He has to know what tool you have to use, that's it. What tool I have to use for this diagnosing. Once the diagnosing has been done, all the reports will be given by the system itself. And the maximum, I will say, after the 10 years, medical transcription, the medical transcriptionist will be acting as a doctor. Now the medical transcription is an interface between a doctor and a patient. If you go to the US and all, so the doctor will read the history of the person. They will they will speak everything. That will be given to the intern. Will be given to the medical transcription, and the medical transcription they will type. That's it. But now what will happen in 10 years? The medical transcription knows everything. Instead of the doctor, the machine will do everything. So what will be happen? We can avoid the doctor after 10 years. Everything will become a machine. The machine will dominate. Right. For that purpose, we have to make the learning that it is done with the machine learning. And see what this neural network does. It is again the subset. See, artificial intelligence. The artificial intelligence subset is a machine language. And machine language is having some limitation where the neural network will start from that machine. Machine learning can do only certain limits. They can learn, they can execute. It is because that is a mission. Whatever you teach, I will do. So today I teach AI, you will execute the AI program. Right? But you may not know what is deep learning. Next day I will teach you deep learning, then you will say that you will work with the deep learning. So whatever I teach, that will be learned is machine learning. And there is another concept, neural network, that it has to understand from different perspectives. Even whatever you have not been taught, I have to understand. Reinforcement learning. So I have to learn from someone. My teacher have not taught me. I went outside. I have learned something. Right. And again, if you see what is the another subset, that is now we are having a CNN and several algorithms in terms of this deep learning. Right. The deep learning, what the difference between what actually the deep learning does is that whatever we are observing, it is making 100% positive. It means, see, the machine learning will give an output. Don't think that that is exact output. It is an observation. There is a possibility of pass, fail. Right, a best, worst. There may be a chances. based on the input what you give. You just take an example of ChatGPT. So the ChatGPT will give an answer based on your question. You just ask, write me, explain something about AI, no? They will give some general things. If you very specific to that content, that if I want a linear regression program, then it will give a linear regression program. Right. So what I want to convey from this is that, so the deep learning makes a very sense that, right, it will make whatever the decision is made, what they are going to do is that they are going to assure that the decision is 100% correct. Right. See that the machine language, it gives a result. Either it is wrong or no, I don't know, because that is all based on my test data. Whatever the data is given to me, according to that I have learned and I have given an output. But the deep learning is something different. It will assure that whatever the observation I made, there will be an validation on that on the result, and they will say that this is what the right. So now we are into this deep learning concept. So that whatever the program I do with the deep learning, you can assure that 90% whatever the output is given is right. So now we can make a classification like this. If you use ML, it has certain level of output, and if I use neural network, the output is something different. And if I use a deep learning, so that is what these algorithms are: CNN, RNN, GAN, GBN. Again, I am saying that these algorithms are all available. So no one expects you to create new algorithms. Right? This Python program is an open source program. So for another 20 years, that is going to be dominated, and we are going to rely on the Python program because each and every day it is getting expertise. Right? So this is what the general thing what you have seen so far. And coming to my point, right? So linear regression model, a simple AI implementation. So we are going to see how we are going to implement AI. So here I have taken a simple model called as how to predict the house, right? A prediction of house based on certain characteristics. So I can give any inputs, right? It's right now. So I am going to train a data. I will show you how we have to train, and you can just go to this tool here. There are two tools I have mentioned. Replit, right? It is an online compiler. Now if you type it in your mobile, you will get a compiler. And whatever the coding I have written, you write it and see that you validate immediately and tell me whatever the errors are. And if you just type, right, online Python compiler, the first output will come as interpreter. That is also one of the online compiler. You need not install the Python at all. Immediately you can run the program and you can check. Right? So these are all the two links. You just go there and just type it. The second link is interpreter. Just type in Google. The first link what you will get is the second link, and the another link you have, that is the Replit. So why I have given the two link is that the Replit will requires your login, your username, password. So you have to go with your login process. But here there is no requirement. Directly you can go and run the program, Python program. Whatever I have shown here, it can be run. So today what we have taken as our challenge is that I am going to predict. I am going to show you a program, right, which is called as an AI program. And why it is called as an AI program is that it will done an automatic prediction. So who will do the prediction? Human being. Instead of the human being, the machine, I am making the machine to do the prediction. So that we call it as an AI, the program AI here. Right. Now the first two parts. Whenever you write a Python program, first part what you have to do is that you have to include all the necessary library files. So you all know that this is how you go. See, import numpy as in. You all know that as I am assuming that for the past 2 days you have undergone an AI seminar, so that you could have known, because AI in the sense you have to know what is Python, no other Go or R program. Anything you want to implement AI, the thing is that you should know AI or R programming. So I'm thinking that you are aware of this Python program, right? So I need not explain very in-depthly about it. And I'm thinking that considering all of you that for the past 2 days you have undergone it, so this NumPy is a library file which is used for arrays and all the programs, whatever you do in your Python, I have to import it. And next see that, so I am sklearn model. And a sklearn model is a model which is actually using the trained data. Right? So I will say, program, whenever the program comes, I will say how that for that purpose. Right? And see linear regression. Again see that linear regression, you are not going to write any program. Be very clear, you are going to just call a library file. That's what I am telling you. It is very simple program. Right? The AI program, please don't think that it is something very hard. Please throw off the myth. Now, from now, you think that the AI is a very simplest program. Anyone can write the simplest AI program. Even in class 8th, right? In my son is studying 8th. He has AI in his syllabus, and he does do the programs, the linear regression program, and all. It is in the list of practicals for your understandability. So it is very simple. It is only 10 to 15 lines program, but you have to understand. See, if you come to the end, you will be able to understand how simple an AI program is. Right. So after that, you see, you are just see here. This is the linear regression. You are just calling linear regression. These are all the syntax. Right. Here it is a syntax. And then see, import a matplot. So what this matplot will do is that finally it will create a what? That's a graph. So that you need not do separately. We are having n number of data visualization tools. Right here, Python itself it is having an inbuilt tool. So you call the MATLAB, right? So matplot. So automatically it will create a graph. That too you can see. That is the first part I do. Right. The second one is the second part like synthesizing the data. See here, synthesizing a data from household. What I do here is, first see, NP. The NP is the variable object I have created here. For that NP, right, dot random dot seed of 0. So this is the function which I start with a array value 0. Right. So I will explain. Next see that house size, house price. Two variables I am declaring. That you can declare A, B, whatever it may be. It is only a variable declaration. So how the house size is determined? See here, how the house size is determined, that is NP. That is what I have defined here. Dot random integer. Right. I have given a value here 1000, 5000, 50. What I am saying here is data. So start from 1000, end up to 5000. You take a 50 sample data. But what will be the output if you just run? Right, after writing these two lines, you just type here as print house size, print house prices. You will get 50 random values. That random values will be from 1000 to 5000. That is our wish. You can give data. So what I am doing is that house size. Size is that in terms of the square feet. So what I am deciding is that my house size, whatever I am going to say, is going to be between only 1000 square feet and 5000 square feet. That's all. So I will not accept more than 5000. I cannot give any answer below 1000. That you be very clear. So that is based on that information. So I have created, see, I have taken a 50 samples. Right. Next, see how the house prices are calculated. I am giving an input that 150. The 150 is a value, some value. So you are fixing for 1 square feet. So that will be different from place to place. So that a constant value, along with that the house size, whatever the user is giving, because I have to predict. Right, I have to predict. So whatever the user is giving, I have to predict the house sizes. Then plus NP random. See here, NP random dot normal of 0 to 1 lakh, 50. So what I am going to do here is that again I am going to take a samples. It is 0, from that the amount, it may be up to 1 lakh. And again that too, I am going to take it only for the 50 because I am going to select the 50 values. So for testing, right, for training, I have selected only 50 values. That is what the output is. So now what we did, just declared a variable. If you take an addition program, so integer x, integer y, I am declaring two variables. And for x, I am giving some value, for y, I am giving some value. That is what I have done here. Nothing more than that. See, two variables I have declared, and I have declared and I have said what the two variables are. That is called as the synthetic data. I am generating a synthetic data. Right now, after that synthetic data, see here, what we did, we started importing library. So here see, what we did above. So what we have did here is imported the necessary library files, and then we have generated the synthetic data that I have written in a writings for your understandability. So whatever I have explained here, so I have written here. See, you have to started importing the library files. See here, it is from so all these things, the skit and all. So how it will be helpful? What see matplot for plotting graphs. Right? See here up to this. So you need not do anything, everything we have just imported, that's all. Python program, just we have imported the library files. And then I have generated some synthetic data. How did I generate here? See that we have created synthetic data for house size and prices, variable declaration. And then I have made a relationship. Right? So for every size, the value will be changed. For that, I have made a training. And that I told a value into some values, no. So that I have made it here. So you could have seen that linear equation. So I have given 0, 1 lakh, 50. This is the input to the linear function. That's all. Now you see. So here the understandability is there. Right? So what I am doing here, the third stage, I am going to reshape the data. So what is reshaping the data is, so whatever the 50 inputs I am getting, 50 selections taking from the that is database, so it will be in a different order. So to make an analysis, I want to make the data into a table, that is row wise. Now see, initially the data will be all the 50. If you run the program, you can see. Right? So what will happen is that the house values, 50 values will be in a single row. What I want to do is that I want to have a 50 rows. So 50 rows of that is the house price, that 50 rows of that price, that is square feet. This everything has to be resized. For the resizing, reshaping, what I am declaring here is that I am declaring two variables. Again, I am declaring two variables. So here, capital X, small y. The Python, be very clear, and otherwise you will get error. It is capital X, so that's what I made a confusion here. Because if both are capital, you will not understand. So that, see, capital X, small y. So at the time of printing, you should see that it is case sensitive. You have to give it as X. X sum, X and Y. What this X is doing, house size reshape, -1, +1. So what this, from this linear regression program, you understand one thing. So -1 and +1. The +1 is that value what you are selecting, and the -1 is the value which you are not selecting. There are some values which you will predominantly select from the database, right? So you have to select it. And then see Y, it is an house prices. So now what I had is that if you type this and if you see your table, so X, it will be in a one row and Y will be in another row. So the X row you will be having the house sizes. That is how the sizes, 50 sizes will be there in a first row. Right? First column. And in Y, the house prices will be in a second column. If you see in row wise, first row you will be having house size, and the second column you will be having house price. Then for row size, then again from the size size price, there will be up to 50 rows. That is what we have selected. So for what purpose we are selecting here, that is what I want to give a training. See, I am having 1 lakh of data. Among the 1 lakh of data, I am selecting only 50 training data. Only I am going to give a data for 50 inputs for training. Next, what I am doing here is that I am splitting the data. Now, this is a crucial stage in your analysis part. Right? So, what you have to do is that you have to split that 50 into training and testing. Among the 50, you have to select or 30 rows, select some rows for testing and some rows for working. So first what I am doing here is that for training, and next one I have to do for my testing. Right, now be very clear. Among 1 lakh of data in a database, I have selected 50 so far. After selecting a 50, I made it into a rows and columns with help of just 2 lines. We see that with help of just 2 lines, I made using Python, using 2 lines, I made my 50 tables into a rows and columns. And next, I am going to train it. So the machine will train. See, you need not train at all. The machine will train with the data. So what you have to do, you have to call the library files. See here, just call the library files, they will train. But you have to say the machine that how many data you are going to train and how many data you are going to test. Right now, so for the prediction, first you need to train, then you need to test. So training, testing. So then only they will come for a new prediction. Right, so this is the logic. So the logic of the AI is you have to be trained. So don't worry about the training and the training will be done with your program. That you are this particular statement, right? They will train the database automatically. So what is the training here? For example, you give 1,120 square feet. For the 1,100 square feet, the rate is around 20 lakhs. And then there will be a next data. That will be around 1,500 square feet, where the rate may be only 80,000. So they will understand why it is under 1,50,000 there and why it is 80,000 here. Because in our state, you see, the rate will differ from the place to place. Predominantly, if your house is there near your main road, the rate is different. For the same construction, if it is interior, that is something different. That is what the training which I am going to give. But as we know, so we are all trained. I want to make the table to train. So what I am doing here, see, x_train. That's all. You have to give this statement. So the library file will be called, and the x, what you have given x here, house sizes. All the house sizes will get trained. Right. So then see here, x_test. So what I have to do? I have to test. After completing the training, I have to test. Right. So what you are testing has to be given here. See here, size is equal to 0.2. So what is the 0.2 is that 20%. So among your data, you can give any value. If you give 30, if you give 0.3, they will select 30% of data for testing. So what percentage you are giving for training, what percentage you are giving for testing will be deferred based on your input. This is what we have to decide. This is the way we have to decide. Now as of me, I have decided that, see here, the XY test size, you select 0.2. So now for testing, I will select 20%. So now I have 50 fields. Among the 50 records, 20 records will be used for testing, and remaining 30 record will be used for the purpose of training. So 30% I will use for training, 20% for testing. So this is why whatever the input you give, accordingly it will differ. Algorithm to algorithm. So you may give the same input to the different algorithm, you will get a different output. Because that you have mentioned in the terms of training. So I have given a small amount of training. For example, I teach only 2 hours and I make you to write exam. See what will be your outcome. If I teach 50 hours and I make you to write exam. So the correlation between the number of hours what I teach and the number of the test what you have scored, we call it as a direct variables. So that will get affected. So here, for sample, I have selected, I have mentioned that only 20% to test. So the number of percentage you are increasing for testing. So what they will do is that they will give you more prominent results. Right. So after making all these things, these all statements are the syntax. See here, x is a variable, underscore train, that's all. The word you use train, the Python will train it. The machine learning algorithm will train. Comma, x underscore test. What you have to do? Train the data, after training, you test it. Again what I am doing? Y. You train the y, small y. And you test the y. So this is variable. Equal to, what I am doing? Train underscore test. Underscore split. Right, how I am split? This is the syntax. X, capital X, comma, small y. Test size, that is I have selected 0.2. And here the random state, that is any value you can keep. I am telling that you start from the record 42. The first record, what I am saying to the compiler is, so you start from the record 42. But what they will do, first record will be 42, then they will randomly select. So randomly I have to give some value from where it has to start. So you can give 9, you can give 10, you can give 11, any numbers you can give. So based on this value, so the answers will be also different. This is a random number. So this 42 says that randomly you select. So the first thing which I have to mention. For example, you are listening a song which has 1000 songs, right? So randomly, automatically it will start from some song. So the some song, what it has been mentioned as the state here. You have to start from 20. Then next you will go for 35. Then you go for 95. Then you go for 1000. Based on some calculation, it will happen. But the first song, what you have to play, that is I have mentioned as 42. That is the data. Then that's all. See here, you are creating a model equal to linear regression. Just call the function. That's all. See, the linear regression program is called in one line. You call, this is a linear regression function which I am assigning to the model. So model is an object. And for that model object, I am fitting. This is an parameter. Right? Model.fit x train and y train. All the trained data you are fixing into a model. That's all. Your algorithm is got over. It will automatically run. Now you see here the explanation what we did here. So reshape. First part, the third part we have reshaped. The data has been reshaped into the input requirements. So how the linear regression is expecting, accordingly I have rows and columns has been defined and I have made it. So the table was in terms of a single row, I made it rows and columns. And see, I have splitted the data. The data has been splitted in terms of rows and columns. Right? So and then I have splitted which are all the things to be trained, which are all the things to be tested. Then finally, I have created a linear regression model. Right? With the help of the SEI Kit-Learn algorithm. So that is a library files which I have added in the first part. Just I have added imported the library files. Because of that, because of this thing which we have imported, now I am able to just call in one line the program has. And the last part, right? And the last part, what I am doing here is that, so making the prediction. This is what your AI algorithm does. For that prediction, what I am writing here, see, prediction is equal to model. So the previous states, you see that. See here, we have fitted here model. Model I have called a linear regression. And to that model, I have fitted all the trained data. I have fitted. It is only in one line. I have done it. And next, if you see here, what I am doing is that again another object prediction. For that model.predict X data. All the trained data will be transferred to this prediction, and now what I will do is that here I will plot it. What do you mean by plotting? I will create a graph. In the graph, what I am doing here is that, see, this is a type of PLT dot scatter. That is a type of graph which we are calling. It is simple one, right? So we are putting all the X data and I am coloring it as a black. So what are all the data trained will be in a black, and what are all the plots which you got a prediction will be in a color blue. If the color black and blue are in the same line, then you can say that whatever you have predicted is right. That's all. See that algorithms, see here, what I did here, the X and Y, that whatever I have tested here, X and Y, it is black. See, trained is different, tested is different. So whatever I tested, that all will come under the black, and whatever I have predicted will be come under the blue, and then you showcase what is your prediction, what is your house size, what is your price. Now, for whatever the requirements, so if you ask, you will be able to select a state, Kerala, and you specify some locations. On the locations, so if you give a square feet, according to the street and locations, they will tell that this will be the rate for the house. This is a simple AI program. So here you see, everything is inbuilt. What you are using here, you have to think like this. This is a very simplest program for which we have to understand only what we have to use. What are all the library file I have to use, how I have to call. It is a basic sense. And if you know C programming, that's what they are saying, it is very easy to understand Python programming even if you have learned C. That is a very difficult C. Now it is very simple. Right, we have understood how this program works. And now you see how you have trained the data and how you are predicted here, finally how you are plotted. So whatever we have written in a coding, now we are executed. Right, see how many of you have just answered to your conscience that how many of you have typed and checked out. Immediately you could have checked. See here, there is no need of any time because we are all computers. We are all under the banner of computer science. The computer science is not yet another commerce or economics. So we have to be predominantly, we have to be aware. Anything may change in the next second. We have to be updated. So you just tell me, in what way you find difficulty in writing a simple AI program. So that's what I will stop now. You have to tell me in what way you find a simple AI program is difficult. So for whatever the myth you could have, please check down with it and tell me what difficult you have found out in this program. Even an 8th standard student is capable of writing a simple AI program. What is there? You need not have installed a Python program. Everything is with us now. Even sitting here, you can write a program, run and say that I have run a AI program. And going with a different algorithm. That's what I am saying, that using different machines. A doctor who is using a outdated or a scanning machine, he will take long time to diagnose it. But now we have a very new advanced technologies where within a fraction of a second I can diagnose and tell. That's the difference. The algorithm what I am using now, this is an algorithm which has been used before 10-15 years back. If even that is called as an AI program, then why can't we write a simple AI programs? So we have to identify the problem, that's all. And what I have identified a simple problem, that is, so we have to find out the house. So we have to find out the amount for the house, construction of the house. That's what the simple problem I have taken. Right. Now you just tell me, what is the difficult part in this Python program? And why we hesitate to do these programs? This is my question. So that to go to the next agenda, the first is completed. right? So if you have done, if you have used your mobile phone and done it, so you could have been able to see that output. And even you are not able to do now, please take it and go to your home whenever you find free time. Even in the traveling of bus also, you can just open your browser and you can type it and you can see. That's all. That is not, so what I want to convey here is that AI program is not a difficult one. Anyone can do it provided you know, try to understand what algorithm, how it has to be used. Even I am having an advanced machine, I should know how it has to be used. That's what we have to know. In older programs, I have to know how to construct the machines. Now everything is available with us. See that how you are going to use it. The perception has to be changed. That's all. Right, any feedback? Any doubt? We will go to the next part. So I'll just speed up so that please say me. So this is the first part, the first outcome. Right, so to understand that I can also write a AI program. If you are fixed in your mind, then that's the first part, the first outcome is achieved. Right? Can you do it? Right. It will not take more time at all. It is all our interest. So they are calling AI. Please tell to everyone, AI is not very difficult. It is very, very simple. Right. That's what. Now you see, water also, I am not going to explain all these things. I am going to touch up. Right. What are all the features? So have you heard about the term explainable AI? Have you heard about the term explainable AI? So these are all the advanced one which actually it will be prevailed in future. Currently we are using it. So what I have mentioned in the previous regression, linear regression is an old program. Don't think that AI is a new program. It was arrived around 20-30 years back itself. They have written an AI program. It is not a new one, for your understanding. Now we are having this many number of features. Right. First thing is that explainable AI. What this explainable AI does is that whatever the output is being provided by the machine, I have to validate it and I have to say that is right. That is called as explainable AI. So if you are going and giving a blood test, and they are checking the sample and they are telling that this is right, you are having this much of diseases, these things, the list is coming right. So that is a tested data. Let us see how much blood you have to give. That is called as the training. And what you have to test. So I am taking a bit of blood, I am testing it, I am getting some lists. What are all the diseases or what are all the viruses you have in your bloods? There is a list. And if the list is directly given to the patient, what will happen? Maybe or may not be, that report may be right. Please understand, machine language, whatever the program, whatever the output I am generating, may be or may not be. Assuring that this is the right answer, for that purpose, they have used that new concept called as explainable AI, XAI. In future, I will call it as the AI will be called as XAI. They will explain why this is the rate. For example, you say that 200 square feet house, I say that the rate is 1,50,000, right? So here this XAI will say that why it is 20,000. What is the reason behind the 20,000? You could have seen the difference between the ChatGPT and Bing. ChatGPT will give the report. The Bing will give from where the data has been extracted. Have you seen? I think so. You are all using Bing, the Microsoft Bing. See, Microsoft Bing will give any question you type it. You can type it now and see. And they will say that they will provide a result, and they will say that from where that result has been taken. This is called as an authentication. Any result I am providing, I have to give an authentication. That's what they are doing, is that in a blood bank and all, if I give a result, there will be one person, he will check the number, he will sign it, and it has to be sent to the doctor. The doctor again, he will assure, yes, this is right. Because I cannot say generally with the help of the machines, prediction, I cannot directly give that to the patient. So what I have to do, I have to assure that this is the right. For that purpose, we are having an explainable AI, which is going to dominate in the next forthcoming years. Then reinforcement learning advancement. That is what I am going to teach you. What is it? That is also a trending feature. Then generative adversarial network (GANs). Right? What it does is that it is a type of prediction. See, every technique will be does the prediction in a different form. That's all. See, whatever the technique, whatever I am saying here, everything are prediction. In what way I am predicting, that is going to be a different. See, people to people. So I am just very used with one particular programming language. If I say me the error, I will tell what is the problem. If I am I am the best in C program, no. If you tell me the error, I will tell where is the mistake. And if you are well versed with Python, see what is the error, I can say where the mistake is come. Right. So that is what the prediction is. So the prediction is what? So based on the error, I am telling where you have to correct it. Accordingly, see, this is an algorithm, a GANs algorithm. GANs algorithm has a different prediction method. And if you see that NLP, normally we have an NLP, that is natural language process. So here there is an advancement in this NLP. Then AI in healthcare. Yesterday you have seen. So that is in healthcare. So it is predominantly, it will dominate. As I said, after 10 years, all the doctors will be replaced with a robot. And robot will do operation. Already it has been performed. Right. Already we have cars in Bangalore. It is in a testing process so driverless car. Right. Whatever the human thinks. What actually we do, whenever we drive a car, and we know, a prediction, whether I have to stop in a signal. So you are predicting the signal will go for red, so that I have to stop. And whenever you are overtaking a vehicle, you are predicting something. So this is the right time to move. No, I have to stop. This is what the prediction. So how do you get that prediction? Based on certain learnings. Already I have gone on this particular road, I made an accident here, so that I will be very careful. That is what the training data, and that is what the tested data, and that is what the prediction method. So AI, whenever you call something as an AI, it will predict. The assuring the prediction to a 100% confirmation, we have a different techniques. So this is a table. Now you see the Edge AI. Edge AI is that, so it will be done, all the process will be done automatically in the system. I need not have everything in a cloud. They will do it with your system itself. That is a new technology. And see, AI for cyber security. So when the paper was presented, and see that, so there is an AI which is going to come for cyber security, so that they will say you that, so where you have to stop, where you have to start. Right, that is going to be there. And quantum machine learning, so you all know about this algorithm, so quantum computing, that will be another emerging. Then see AI ethics, right, that is the one. And then swarm intelligence. This is also going to be, it is also a method of perceiving. How you perceive, how you interpret. So the interpretation will be done based on what you perceive and what you know. So if I have learnt, so if I am there in a particular place for 50 years, I will know what is happening. So normally if you see any natural calamity happening, that will be known by the dogs. I think so you are all aware of it, you are agreeing with me. Right. So any natural calamity, for example, earthquake. So if the earthquake is coming, the thing will be well advancedly, it will be known to the animals, because they are living with the nature. They are living with the nature. They could come to know that before 10 or 15 minutes, they will shout and they will shout like something so that we will be able to know something is going to be happened. Right? We are all, so this is the prediction. They will come to know because they have that much of data processing and they are aware. So because if you have this kind of symptoms, this will happen. If I have this symptom, that will happen. That is what the training is. That type of input I have to provide it here. Right. And AI in agricultural, I think so you all know. So the agriculture, everything is done by the AI. In what date I have to fertilize it, and pesticides, in which date the pesticides has to be given, and for this particular field, what sort of seeds will be preferable. Up to that, now we are having the, see, these are all prevailing. So in future it will come to every place. So now the grandfather will predict, because they were all working with the farmers, they will know when the rain will come. They knows when what seed has to be sowed in this particular duration. That and all, it has been happened only with help of the previous experiences. That is the data. That is what we are doing with help of the machines. That's it. That the data has to be given. Without the data, nothing is possible. The AI is zero without the data. So agricultural data, if I want to give any valid input, I should have 50 years of agricultural data with me. All these things should be fed and my algorithm has to process, and then because the climatic change, now we are under the verge of this environmental, there is a climate change. So we don't know when the rain comes and when the cloud comes. It differs because initially we had the pattern. There was a season pattern. The year has been divided into 4, and all the 4 seasons will have the same set of process. But now it has duration. There is a changes, and all the changes are monitored, and then it is. So now you take an example in broadcast or forecasting. And the forecasting, what they say is that so tomorrow there will be a rain. It is a prediction. So for next week there will be a heavy rain. It is a type of prediction. How it does? AI is doing. With help of the previous data, I am saying that there will be a storm, there will be a rain. All these are based on the prediction, that too with help of lot number of data. Right. So that's all about this advanced topics. And we are going into this reinforcement learning. So this is the advanced topic. I have selected one topic. Sir, what is the maximum time? Right. So I will just speed up. Just see that reinforcement learning. So what actually the reinforcement learning is? So here simply I have mentioned here is that, see that taking a decision with help of with help of certain experiences. So today I will come late. Because of that I have been marked absent. What will you do tomorrow? You will come as soon as possible. That is called as the reinforcement learning. So whenever you take a chess, the chess players, what they will do? First they will start with a mistake. They will learn the mistake. The mistake has to be stored. And next time I should not do the mistake. The next day what I will do? I will commit another mistake. This is a fact. Right. So that mistake again I have to learn from this. So this type of learning is called as the reinforcement learning. For this reinforcement learning, see that these are all the components. There should be one agent, there should be an environment, there should be a state, action, reward and policy. So system itself, so this algorithm will work like this. It will interact with the environment. According to the environment, they will act. And see that these are all the agents. So I will show the pictures also. So right. So what will happen is that whenever we do some work, I will just go for 2 processes. One is rewarding, another one is punishing. So rewarding, I will give 1 mark. Punishing, I will give -1. Whenever I see I have given -1, I will know that I have made a mistake. And I will see that mistake should not be happened next time. So this is called as a reinforcement. This is a type of learning. Right? So it is a kind of learning, advancement, new learning. And see what I will do here, positive value and negative value. Whenever I go with a positive value, that I have been rewarded. And as much as I get reward, it means that my method of perception is correct. So something I am deciding, how could you say that what I have decided is right? Validation. Some or other place you have to validate and see. And finally after seeing that you will conclude this, whatever the place I am going, it is right. Now see, this is the reinforcement learning see, it is in machine learning. It is a machine learning way. It is the learning method. What I do, I give input. See, this is the input. There are n number of inputs, millions and millions of data. I am feeding it here, right? So this is an agent, the person who works. And what the agent is doing, he is selecting an algorithm. There are thousands of algorithms, you can select any one algorithm. After selecting an algorithm, so he is selecting a best action. According to his knowledge, he is selecting a best action. For example, you take it as a chess, I am going for a first move, thinking that is the best move. And I have to say, see here, in reinforcement, I have to say, if I am moving one step, I have to say why I am not moving other chances. If I am having 10 choices, out of 10 choices, if I am selecting one, I have to give explanation that why I am not selecting the 9. Are you able to understand? So if I am giving, choose the best answer, you are selecting A, B, C, D, among the A, B, C, D, you are selecting C. Right? You should not tell me that why you are selecting C. Instead, you tell me why you have not selected A, B and D. Right? So that is what the learning is. So if I am very clear that the A, B, D are wrong, ultimately C is going to be your answer. Right? So best action, then it interacts with the environment and then you are getting a reward. Right? So if you get a reward, it means that you are in a right position, you are in a right prediction. And what they do, the state. So current state I will be noting, and the next state I will have it based on the reward. So if you are getting punishment, again the state will be changed. So if you get reward, your state will change. State is that place what actually you are doing. Accordingly it will change. So this is what so according to that what you get you are getting an output. So here, see, from here to here I do feature extraction. Here I am classifying. So you should know very clearly that feature extraction is different from classification. So classification is what I am classifying. Feature extraction, so with all your inputs, I am understanding some level of data. We call it as we are having n number of hidden layers. With all the hidden layers, I am getting inputs, right? All the inputs I call it as a feature extraction. And I am getting new things. Now just for example, you see that I am owning a shop, cloth, or fabric shop. In a fabric shop, I am having for 20 years I am having a data. And for the 20 years of data, if I make an analysis, I can say that what will be the trend in 2030? What will be the trend in 2040? Because there is a change, there is a cycle. So that is what the called as a prediction. So that each and every companies are having R&D section. What they do with R&D section, they are finding out what will be happen, what is the customer requirement. Even I am having a small gift shop, I should know what is the customer expectation. The customer expectation can be considered or can be processed, can be known only with help of R&D. So for that R&D, we need a AI. That's what we are telling. In future, everywhere there will be a need of AI to understand the requirement of the customer. So why I have to select this particular institution? There are n number of parameters. So what this kind of people, so after 10 years, so what type of education the students will like? This is a type of, whatever I am saying is all problems. You can find out a solution for it. Now what are all the parents, how the parents are expecting their children to behave. If you have 20 years of record, parents record, you can assume, so you can predict, your system will predict and say, you need not do anything. The only thing is that I have to update that much of data into the database. If you update it, then you will get an answer for it. That's what the AI will dominate. And here we have feature extraction has been done, and here I have classified and I have provided an output. So that is what the reinforcement learning. See here. So we are making good action, bad action. It is decided, and then the agent. See, this is neural network. So the connections will be changed according to the output provided here. Right. So your decision, your training, and the training la I am testing. At testing la I am learning, again I am changing. So this is the process, so that if you train, you will be able to get you can be easily able to predict what is going to be happen. That is reinforcement learning. And this is what the agent policies. So these are all the basic things. You see who is the agent, the person who is making a decision. So if I am working, that is I am agent. The environment. What is the state? Currently, how you are. Tomorrow you will change. See, today you came up with a mindset that AI is very difficult. After attending a session, you have changed yourself, stating that AI is very simple. That change is called as the state. Right? So the current state and the next state. Action. Then what is the reward? The feedback from the indicating success is reward. And so you have a policy. So policy has to be changed based on the rewardings. And so I may think that I am the best. After getting feedback only, I will be able to know that I have to change many things. I will change it. So what I have to do? I have to change the policies. And I may have a policy that the early morning walk is very good. And after knowing some incidents, I will change that. So not good, it may be good in evening. So the policies, whatever we are making, whatever the policy we have, so the policy can be changed based on the actions and the learnings and the outcomes here. And see, this is oral process, right? Markov decision process, MDP. I will show you in an example how this MDP works. Right, so this is exploration versus exploitation, how it works. I'll show with a diagram. And example, right, so here a simple game example that I have it, I will show you. And see how we have to change the policies. Each and every time. So first time when I am, so if I am a computer, I am playing a games with you. Right, the first time I will take a move. And then I will come to know that is a wrong move, so I will change my policy. So each and every time you are changing a policy, it means that you are growing. So learning is what? A change in individual. What is learning? If you ask any definition for learning, the changing in the individual is called as learning. I have to change. So how I was yesterday and how I am today, there should be one change in it. If I have at least one change, then only I can call that I have learned. So that is what the policy is here. And see, there is a working model. You can go and work with Q learning, deep Q networks. So these are all the names. You just type in Google. There is no teachers required for you. Everything is available. Right? See here, Q networks, right? Q learning. These are all the new models which is available. Which you work it, you will be able to understand. And real-time example, that is an AlphaGo. Reinforcement learning, the example is AlphaGo. So if you go work out with AlphaGo, you will be able to understand how what is the logic of the reinforcement learning here. So this is all based on the decision making. Please understand the difference. So you should know the difference between data mining and an AI. Please, anyone tell me what is the difference between data mining and an artificial intelligence? Any idea? We have data mining. It mines the data. It will mine the data from the database. AI. It is also making some sort of decisions. So what makes the difference between the data mining what the data mining cannot do, so that the AI will do. Any ideas? The data mining will identify only the patterns. What actually the pattern that can be identified. But prediction can be done only with help of the AIs. There we have a difference. Predictions, right? Based on some input, I will get prediction. Data mining, based on the prediction, based on the data, they will understand the pattern. What pattern it is. So what will be the next, in what will be the climate, so how this pattern will go. The pattern identification or so extracting the hidden information is what with the data mining, where the AI will go up to that and it says that what will be the prediction here, right? So that's this AlphaGo will do. That is what the AlphaGo. Right. So these are all some advancement in reinforcement learning, DRO, PPO, MARL, MRL. See, again I am saying you, whatever I say, don't think that these are all very, very difficult. See, if you make a comparison between this MARL and MRL, only one difference may be, that is in what way they predict, that's all. So these algorithms, you need not mug up or you need not do anything, already it is available. You try to know, right, what this algorithm is doing, what this algorithm will do. That's it. Then we will be able to use it. So if I am having a problem, you should know what sort of algorithm will be preferable to the problem. That is the only method that you use in a Python program to call the library files, use it, so that you will be getting an output here. That's all. So again, I want to say that it is very, very simple. Don't embrace just by seeing all these names. So what this proximally policy optimization will do? It is a method. It will take a decision in a different way. It is the expertise. So now you see there is a two country which are fighting for last several years, several months, some places, several days in some countries. It is all because of a decision making. There was a decision making, there was a mistake in decision making in some place, because of that we are happening. So the decision making will have different impacts. So that efficiency in making a decision. So for making the decision, what is important? The data is. I should have that much of, I should have analyzed n number of data to give a proper results. That you should have done it. So this is actually a difference between all these things, so that you need not worry. It is not that you are going to use only one algorithm. You be well versed with one algorithm. If you are selecting, see, if I am saying here, it doesn't mean that I know all these algorithms. Please note down. So whatever I am written as an algorithm, don't think that I know every algorithm. No. No one can know all these algorithms. Whatever the algorithm you want, you try to understand only that. Now I am saying that this much of algorithms are available. Right? So this much of algorithms are available. You preferably, you use any one of the algorithm according to your problem. Any problem you understand, try to understand and use it. That's it. Right. So what are all the challenges? Right. So what are all the challenges here? See the challenges like sample. How much sample you are getting? So that is a challenge. So if you want to make a decision, you need lot of samples. Right. If I am having a data, see initially we don't have much data regarding the cancers, but now there are several people who have undergone some cancer treatments, so that we are having a large number of data regarding the cancer. So that now I am able to predict. 10 years before I was not able to predict because unavailability of the data. So for a particular disease, if you want the computer, the AI to understand, predict, so it needs n number of data. So that is the challenge here. For any area, you should have a sample efficiency. Then generalization. And so it should be a generalized one, something which cannot be explored. That in such a way that system should be available, and robustness. Ultimately, that will be a real challenge. And if you see this, another challenge, the ongoing research direction, right? Ethical consideration, interpreting. So how you think, the others to happen. That is called as an interpretation. So how you interpret. See, the success of the AI is actually depending on how you are interpreting. Right? If I see the two people speaking in a different way, so I can interpret as a third party, I can interpret that it is a different form. And by a family member, they will interpret it is a different form. So the interpretability is actually very important in making the decisions. So you should understand. So that is actually a challenge. And the level of transferring. So here I talk about the upskilling and unlearning, relearning. Right? So we have to unlearn something which I have already learned. Right? So I have to unlearn something which I have already learned. For that, what we have to, because I am used to do. For 50 years I am practicing it, and now I want to live it. Right? So if your father or grandfather goes to the hospital and they says that to early morning coffee has to be considered, it has to be removed in this diet. So for 50 years he is having a coffee, no. So immediately he cannot take it. So we have to try in some form and we have to make it as a practice so that then only I will be able to get the success. So that is also another challenge here. And this is what that last algorithm works, the reinforcement algorithm. So see here, this is an example. So this is a maze, right? This is a maze here, right? There are some obstacles. As I said, if this if this agent reaches this diamond, he will be getting one reward, that is a positive. And unknowingly, if he goes to this particular place, so he will be given punishment, that is -1. Where there is an obstacle here, this is S6 is a cell where it is an obstacle where I cannot go through that. Right? So this particular agent can move either to the S5 or S10. But he have to reach this place. So these places are not aware. I don't know how I have to move. I can move left, right, left, right, and other sides. But I don't know where I will get an answer. In the first time of training, I may not be able to get where I have to reach. But your reaching position is here, and here you should not go, and this place I cannot touch. So there are some spaces where to reach the destination. So how your algorithm will work. So see that your reinforcement algorithm. So the image agent, right? It is the very first. I told you that agent. See, the maze is consisting of S6, which is a wall. So I have shown you. See this S6. Right, see this S6, it is a wall, right? I cannot go through it. So what I have to do here? So S8 is a fire pit and S4 is a diamond block. So I have to reach the S8. So for that, these are all the procedures. I can take 4 actions: up, down, left, right. I can move. But where I have to move, someone has to say. For that, what I do? See here, I am calculating some process. Right, for each and every, so this is what your algorithm will do. So I am in a B1, so I am in a S9, and I have to reach the S4. So to reaching that S4, see, I am finding the path. Right. So this is the path which I have founded with help of calculations. So I am having a formulas also. And see, if he is in S1, if the agent has reached the S1, now there is 2 possibilities. Either he can come down or he can go to the left. So what he is actually going to do, that is actually called as a Bellman's equation. I should not again come through which I have already came. Right, for that purpose, we are having a formula here, Bellman's equations. these equations will be processed, right? So for that, so we are having some algorithms here. This is Vs maximum of this formula, right? So as I am running out of time, just I will tell what is the value. So this, based on this formula, so how I am predicting that Vs. So Vs is the position for which I am going to move to the next right position. So what I will do, see here, this is what the value, because with help of all these things, now I have identified that some values. Putting that numbers, I got certain values. So you was in a S9, your value was 0.66. Now I will identify the value. After that, if you go here, according to the value. When you reach V1, it means that you are nearing the outputs. So your output is somewhere. You are going in a right path. For that purpose, the formula will help that particular person. So based on the formula, he is moving towards nice here, 6, 7, 3, 81, 0.9. Now I have reached 1. If I reach 1, it means that the next is my destination. So you can ask that, so how you derive these values? That is with the help of a formula. That is what the algorithm does. What your algorithm does here, they will say that which is the right move. So why I didn't select this S10? Because that value is something different. Because of that value, so someone has to say me. So who will say? So that your formula, that procedure will say it. So that now you see here, it has gone. Now you are having all the values I have calculated. Right. So among that value, so based on the less value, so I will select a particular path. So it is the maze or the chess game or anything. So each and every step I go, I will learn. Right. So based on the learning, I will have a reward list. According to the reward list, so I will act. That is what we call it as. That is the example of the reinforcement learning. So if you implement it, you will be able to solve the AI problems here. Right? Do you have any questions? So another 10 minutes. So if you have any questions, otherwise I will tell the current AI problem. One current AI problem which has been taken by the state government of Tamil Nadu. Right. Right, a recent application. So it is a very recent application. Even you cannot go and see in your websites also. So it has been implemented yesterday in our Tamil Nadu state. So this is TANSDECO is an electricity board. It is a Tamil Nadu electricity board. So what they did here, that is an AI. They want to identify the energy demand. They want to predict the energy demand area-wise. This project is actually running in our Andhra Pradesh. They have made an MOU with Andhra Pradesh, and what they are going to do is that they are identifying what are all the direct variables. The consumption of power, so what are all the variables it is directly affecting is that is the weather forecasting. So based on the weather, there is a chances of usage of electricity may or may not be different. It can vary. So here what they are doing here, so they are providing predictions. They want an automated technique so that they should be prepared. So what this AI tool will say is that for next 10 days, based on the areas, what will be the consumption? It is very simple. So don't think that it is very, very difficult. But it is a very simple, provided you should have a data. So the past 10-15 years, if you have an electricity board data, you feed everything into the computer, right, and you use any of an algorithm here, automatically it will say what will be the consumption required for the next 5 years. So what I can do is that I can distribute and generate the power. There will be some place where there will be usage may be less and the transfer may be more. I will allocate more, but consumption is less. In some places consumptions are high, but the allocation may be small. Because of that, I will get some issues related to the state. That can be overcome now. So that's what, see that, a better reading of electricity demand pattern for grid management. The grid management says that, so what consumption is will be available, what consumption is required for this particular street. Even it will come to the street also. This particular street in this weather, in the winter, how much they are using. And so because we are getting reading, we are having the data of it. And June month, so it is a rainy season, so that what is the consumption. In May month, it is something different, you get it more. So what will be the consumption for next May? So if I see the 4 years data, I will be able to predict what will be the next one. It cannot be just like that calculated, so a lot of information has to be fed in. And see that it helps for an uninterrupted power supply. So again there I can make a classification that, so peak hour processing and so non-peak hour processing. In peak hours, the consumption is more. If you take an internet, you can make an analysis. In peak hour, what is the usage of the internet, and in normal hours, what is that requirements. Accordingly, I can give the freeze. The policies can be set. And normally it is initially up to now it was done manually. All the places, all the state, all the consumptions are recorded manually, and by compiling the weather and the consumption pattern based on the energy data for, so you should have several years of the energy data so that you will be able to predict it. So they create an AI software. Now I want to create a software. So software is what? The tool. So the tool is what you are going to develop it, right, which is already available. Any algorithm now you have to select. What algorithm is preferable for analyzing this electricity data? So it is all based on the type of data what you have, whether it is in a database or not, in what type of database it is available, based on all these things. So how it can be extracted, whether it is in a Excel or MS Word, or whether it is in Access. Like this, accordingly you have to select one algorithm. Right. Now, another the last live demo, that you can test yourself that you can itself, if you go to this slides go, you can create your own presentation. That is also another AI tool. So now itself you can check down and go to this slidesgo.com. You can create your own AI presentations. Any presentation you want. Your teachers are giving some assignment to you, prepare some assignment. So you just give to this AI presentation, they will prepare and they will give. You need not try it. Within a fraction of a second. It is also an open source. Right, see this kind of tools, there are several tools. It is not one or two tools. But I am giving a sample. So everything is available in the internet. So I have not taken something from some other place. Everything I have taken from only the net. So source is available. Right. I want to conclude that everywhere the source is available. It is all up to us to understand and extract that information. And I want to summarize what we have seen so far. So we have talked about our theme, like today's theme, that is AI, and we saw what is ML, what is neural networks, and what is deep learning in the first slide. Then we have seen how the linear regression works. So Python coding, using Python coding, we have seen how the linear regression works, a simple AI implementation. And then I have listed out some features, AI features. In that AI feature, I have selected one feature, reinforcement learning, and I told how the reinforcement learning will work based on certain algorithms. And I have given two live examples, right? What electricity board in Tamil Nadu does AI, and what actually an AI presentation is about. So this is what we are seeing. And any clarifications, I am ready to clarify. That's all up to my talk. And anything you want to clarify, I can clarify. And I will share my number and mail ID to your administrative team, right, so that when and wherever you want any clarifications regarding the Python codings. If you have any doubt on it also, you can connect with me. So I will answer to you. Even if you are not able to ask, so the hesitation always is a very obstacle for our development. So whatever we say, you cannot understand it, but you have to come out of it. Then only the success will come with you. Otherwise, the person who is actually active will get everything. That's all about my talk. So any doubt, clarification, you can come to me. Thank you. And in this junction, I would like to thank all the participants, the committee members, and those who the management of this institution. I am very thankful for everyone for making me to be here and share my expertise. And I would like to thank all the participants. Even though it was a long session, you are patiently listening to me, so that see that whatever the outcome, as I told, see that whether you are getting it or not. If you are not getting it, then there is a problem with our initiation. Okay, thank you.
Our heartfelt thanks to our esteemed resource person. I would like to invite Fatima VK.
I extend my sincere gratitude to Dr. M. Lingaraj for sharing valuable insights during the seminar on AI's current trends and future prospects. Your expertise has enlightened us, and we appreciate your dedication to advancing knowledge in this rapidly evolving field. We are truly fortunate to have Dr. M. Lingaraj guide us through the intricate landscape of artificial intelligence. Your passion and depth of knowledge have not only broadened our understanding, but also inspired us to explore the limitless possibilities that AI holds. Thank you for your time, wisdom, and commitment to sharing the future of this transformative technology. Thank you, sir.
Now I invite Dr. John T. Abraham sir for presenting memento to Dr. M. Lingaraj as a token of our appreciation. With this, we come to the end of this session. Now it's time for lunch break. 2 counters for veg and non-veg. You can choose according to your wish. Everyone is requested to be back here by 2 p.m. Thank you.
Anything that you see, the advancements that you see in common man, the power that is being given to common man is all because of this gadget that is available with us, which was not there with us 2 decades before. I could never imagine I could watch a movie in my phone when I was an undergraduate student. So from that days we have gone a lot, and then these kind of programs are all because people may think you can get a certificate. But if I ask a question, how many of you will attend a program or a workshop if your teachers are telling there is no compulsory attendance, there is no certificate that you get? How many of us will attend the program? Somehow, when you blame about the system and Kerala is not growing and all, we have to understand how much of intellectual quality that we all have in us. And if you attend an examination and if there is no teacher to supervise, and if everybody else is malpracticing, what is your character gene that shows? How many of you can refrain from focusing on what you know and what you write? As long as we don't have the gene in us, there is no point in blaming the rest of the country. Our politicians are not good, Kerala is not good, we have to migrate to other place. How much quality that you have, and that shows the class, and that will be always available. I really congratulate all of you for taking time on a Friday evening in spite of compulsion maybe from your teachers to fill up the auditorium, because I know how difficult it is. I have conducted many programs. It's very difficult as an organizer to fill up the audience. But if at least 5% of the audience get translated to events where 10 or 15 years down the line, you speak on behalf of me in some part of the world, then the purpose and the effort that has been done by the teachers, the coordinators are being done. We should be rather thinking about what I can get, that is not important, what I can give. Okay, and then when you look for in the job market, people are always asking, what is the pay package? What will I get? How many of you will ask the employer, in what way I can contribute back to the growth of my company? What is my profile? If the moment the earlier in your life you make your thinking process into that, then you are an asset to the country, you are an asset to the institution where you learn. With this background, let me take my 15 to 20 minutes in addressing about this topic, role of multi-core processors in machine learning applications. Okay, so you start your day with your digital gadget, right? And the last day what you do is the digital gadget. Okay, so if you have posted some picture in Facebook or WhatsApp status morning, first thing what you do is how many views? Okay, I hope you know Malayalam language, many of you. Okay, Enda Moham, Enda figure. That's what you see in the movie. Which is that movie? Where Srinivasan is talking. Udayananda, those who are not. We are always about that infatuation of how people come and okay, this blue tick is a problem. You know what is called a blue tick problem in WhatsApp? Somebody has seen my message, but they have not replied. That is called blue tick syndrome, which reduces the productivity of 50% of Indians. And the people who invented WhatsApp is happy that 50% of the idiots of this country are looking at blue tick syndrome. My boyfriend viewed it, but no reply. My girlfriend viewed it, no reply. My cousins viewed my photo, nobody is smiling. Now we are generating programs such as the moment you view, even if you are not clicking like, it will automatically generate like so that the rest of the world is happy. So applications and handheld devices are part and parcel of our day-to-day life, right? Don't know, somebody tell this app is good. Play Store, go and download, and you never know whether this app is really making sense to you or not. And after some time you realize your phone is slow because you download not many junk applications and then you complain your mobile phone is not up to the mark. Then you save money or you ask your husband, you ask your wife, wherever it is, and then go and upgrade the phone. And when you upgrade the phone, then suddenly you feel fantastic. Again download many applications, so that's why you drive. And this is what we do. All these applications are running on some kind of a gadgets. So the future, have you ever thought like this kind of sophistication that we have 10 years before, it's very difficult to visualize. I don't know whether there exists a class called drivers. The driving license will become a bedtime story. Maybe you will tell your grandkids, once upon a time, during your childhood days, there was something called driving license. There is something called steering and brake in the car. Then your grandkids will ask, Amma, Appa, what is steering? What is brake and clutch? No, you will see driverless cars. You just simply sit and then things will be vanished. And then you can learn any degrees, any colleges. There may not be teachers also, probably we don't know. You can switch on to any channel and you can watch anything that is being required. So we are in a challenging world. What are the capabilities of this hardware that will help us to use these applications? In a country like us, Now in Kerala, we find a peculiar syndrome of a typical other language speaking community getting flooded in and around Kakanad. And we call them with a sweet name called Bengali. Right? Why it is happening? We don't have enough manpower in our state so that they can do some law and work in our farms. So we migrate them, and then just like the way we consider Gulf as our own heaven, if I speak to, because I come from Assam, if I speak to any Assamese or Bengali people there, once I was moving through the street and then hearing me speaking then Malayalam, he was asking, Chetan enda ivide? Then I told, Chetan didn't get a job in Kerala, that's why Chetan is in Assam. Oh, you didn't get a job in Kerala, you came all the way to Assam. So we are all going to Kerala in search of job. So here they feel like people are moving out or we don't have enough people to work in these farms. We in our country have to generate 140 kilogram of food every day. What is this? 140 crores kilogram of food. Assuming that you eat 1 kilogram of food a day. Now in the food court I was seeing all of you are eating more than 0.5 in the lunch itself. So it will go to 1.5 kilogram of food a day. We have to produce it. Who will produce? AI will not produce food. Some farmer has to put in the seeds and then it has to grow. Only thing is the manpower in to take care of the seeds, that is not there. So how can you do that? Future thing will be like this. US is automatically done it. We have lot many farms where lot many, if you go and talk to your parents or grandparents in villages, they will tell, funny nobody is there to work. So we are outsourcing. But then lot many North Indian states, they have already migrated into this kind of smart farming where agro robots are there. They will go and help, they will check the manure, what is required, what is the kind of manure, they connect to weather forecasting system. If it is going to be raining tomorrow, there is no need to water it today. So that's the way lot of smart farming that is going to come. Any project that you do in the field of smart farming, next 10 years of your work or career is best. Lot many startup companies are there who are coming up with the products which can be put into that. One biggest problem that Kerala, the land of coconut trees, was facing is there is nobody to climb the coconut tree. Now we have come up with solutions, with mechanisms coming. So future is your robot will go and then you have a dealing with the robot. Hey, this is Onam, you give me discount 50%, okay. 10 coconut tree I will go, you give me 50 rupees. And he will, the robot will tell, a Google Pay account. You cannot imagine 10 years down the line what all things you are doing. So when I went for a competition in IIT Delhi, then I was asking what is future washing machine is all about. The washing machine will have a robot that is going to assist, because now the problem is you have to go and open washing machine and put. The future robot will smell your dress. If it is above a threshold, they will snatch it and then go. So that will create a lot of problem to the young generation who keep on repeating jeans for 1 year and then you don't change your dress, and if the robot is sensitive with the threshold smell, if anything that crosses, when you walk away, robot will snatch and then that will become robot getting, or people getting raped with robot. That also will happen. Because you are going to be stripped on the street. Why? You crosses the threshold smell limit of a good dress can be. So smart farming is an area where you can come. You can see that drones checking out many things, whether animals are there, and accordingly you can generate it. Kerala is very fortunate to have good hospitals, even though we keep on crying to central government, we didn't get AIIMS, we didn't get AIIMS, but then we have a lot of good hospitals. But that is not the case in many other parts of the country. See, in COVID we have proved that our traditional concept of school education or college education is teacher has to be there, the student has to be there, they have to be inside a room. We broke the barrier. They can be from different continents. And many of us attended multiple meetings together, which is impossible. In the mobile phone, one meeting is going on. In the laptop, another meeting is going on. I am present. Like Kumbidi. In which movie? Omnipresent. So like that, we have seen this. Now what is going to happen in the future is, do you require a medical practitioner or a doctor to be present in the same room where the patient is present? Need not be. What if you have, this is a doctor doing surgery in US and this is the patient in London. In between there is a small sea called Atlantic Ocean of 8,500 kilometers. That's all. Width. So the signal that the way how the doctor moves the arms and everything, automatically the robot will cut the surgery over there. Future hospitals are going to be like ATM centers. In my college days I used to wonder, how this machine will give me currency? It is very difficult to believe currency is coming out. You are a generation where you have born into ATM machines. We have seen going to the bank, giving check and they give currency. Now it's see, future hospitals are just like this. You go into an ATM counter of a center and then you tell what you want, English or Malayalam or Hindi, you press. What is your disease? I have throat pain. Then they, whatever the doctor is telling, what will the doctor do? When you go to a hospital, if you get throat pain, if it is a good doctor, studied in a good college, at least they will ask you to open your mouth and then the doctor's camera will work. And then whatever they have copied over the years into the brain, they will compare. Okay, this throat means chapter number 34, page number 2. Oh, that throat, this is throat infection, this is the medicine. That's the way how it is going to work. If somebody is not that interested, can you please go out? Yes, please go out if you are not interested, or else don't disturb. Okay, yeah. So, if in such a kind of, teachers don't get worried, okay, it happens everywhere. It's the same breed, so it's not a problem. So, what happens is, if your doctors need not be physically present in the same room, so then you kind of an interaction. What if, have you heard about heart attack? It's a major cause of death for many of our, we have heard about many of our family colleagues or someone might have got it. Will heart attack happen all of a sudden? No. It's because of a block somewhere there. Will the block happen all of a sudden? No. It develops over the years by eating kurkura chips, KFC, all of the things that you do, and mama's own fried chicken, whatever that you eat. So it is like a vessel getting filled up with fat. What if you have an equipment that is implanted and telling you, John, if you eat like this John or what John, whichever John it is, if you eat like this, 2024 April 1, you will die. The moment you see the message, you will immediately die. So if you don't have that much willpower, you send the message to the family, your spouse or parents, then they will die. So it is an ecosystem by which you could predict how the health situation is. When you are all born, your parents were handed over a book. Do you know what book it is on the day in which you are born? Some teachers or mothers, they will know. There is called a vaccination chart. At this age, you have to take these vaccines. 2035 onwards, there is a vaccination chart, there is an implant chart. This chip has to be fitted in kidney in this year, that year. So the body inside will be a lot of sensors. It's not comedy. And they will be live watching your blood sugar level, your cholesterol level, many other parameters and give you warnings that is being connected. Okay, nowadays we will get, even just 10 minutes before, I got a call from ICICI Bank telling that I will give you free credit card. Then I told him, what guarantee you have? So you will get this advertisement messages. So future phone calls will be, I am calling from kidney. If you eat like this, kidney will not last. Then they will tell, no, I am taking class, I will call you back. These are future calls. In short, what I am telling is smart healthcare, where computer science joined hands with biologists. I took engineering because I was poor in biology. But in IIT curriculum for a BTech program, first year it's compulsory biology. Because any course that you study without biology, it's very difficult to correlate. So if you wanted to develop devices, machines and softwares, you should know how human body works, how an animal body works, how a plant body works, and that's the way how you connect. Yet another aspect is smart homes. When you go and open, see, you all might have got some scolding from your parents or spouse for losing keys, right? Now this also will become bedtime story. You tell your grandkids, I got scolding from my mother for losing the key. Then your kids will ask you, what is key? Then you will show, key looks like this. Future doors may not have any keys at all. You already have biometric locks. Now think of future homes. You have to go to the door and then smile. Then the door will open. If you had a fight with your teacher, if you had a fight with your boss in the office and go with that shabby face, the door will not open. That is the backside of AI. Because your smiling face is being recorded in Zoom, and if you are not smiling, come back home with a pleasant smile. If that is not happening, smart homes will not work. All the switchboards, what you see here, will not be there in Bharat Mata College in 2050. You look at the fan and then tell on. The fan is on. You tell 2, 3, gesture recognition. See, this has to be converted to 2 volt or 3 volt. The idea is simple. Computer science joined hands with electrical engineering and then we make wonders. So smart homes are every gadget. Sitting from here, I can control the AC, I can control the washing machine, I can switch on the fan. And you might have seen in some places also visited airports or good hotels. If you go to washroom, your homes, If you go to washroom, you have to open the tap like this. You all had that first experience of going to some place where you don't see that knob to open and then you will wait. Why? Somebody else will show the technology. Every one of you at that first day where you struggled, there is no knob. Then you show the hand, then water will come. Then kids are so fascinated about it. And then all those who are now looking forward, they will go and put something there and then see whether it works or not. And same is the case going to toilet also in foreign countries. You don't have any water, any paper there. Then you have no idea from where water will come. How will you take care of hygiene? So technology has advanced so much in sustainable development. Intelligent transportation system, which I already told, future cars are going to be. So driving license will become certain job role, the vehicle, the transport commissioner or the assistant motor vehicle inspector, that job itself will become obsolete. Whom you will find? The robot. Now what if a driverless car violate your Kerala's AI camera? Who will the fine will get? So even the cameras also has to come back and learn. Who will do all this? Politicians can only make policies. We want intellects to solve this crisis. How these intellects are created? In colleges, in campuses, in programs like this where you get exposure outside your subject. And then you go and outside and see industry, what is been happening, you get inspired. If he can do, I can also be part of it. That's the way how you grow. Intelligent transportation system. High precision security devices. Now your CCTV camera only will catch what is there and you have to re-record and then see where it is. Future intelligent cameras, we are actually working on this. That itself will tell where is the anomaly. So I need not store all the entire night full video. I need not store. It will store. Now intelligent camera means if everything is, suppose if I fit a CCTV camera in a corridor, if everything is going smooth, I need not even record and save it. Can I look into the content and find, okay, there is some anomaly here. This is my area of interest of the video has been stored. Then you do like that. So high precision security devices. In future, if you simply pass through the name, roll calling, everything what you do in attendance, it may not be there. UGC will come and tell that you fit up a camera, every student who is entering, attendance is recorded. Oh my God, and how will I put proxy? How will I call attendance for my friend? How will I sign for my friend? The moment you enter into the college, your face is recognized, your attendance is been marked. Now, even teachers who is in and around Bharatmala College is also worried. Then how will I go in between out and then come back? Everything is been recorded. So recording is good or not, we will deal it later. Weather forecasting. 2004, December 25, India learned a big mistake when the tsunami happened, when the eastern coast of India, Bay of Bengal side, suddenly the sea water came in and we had no clues. Now, in Bay of Bengal, we have sensors. Any earthquake that happens, any tsunami that is happening, we are able to. There are a lot of cyclones that is happening. We are not losing life, and except in Oki, where we never gave that seriousness to the input that is being given by the weather forecasting team. We are able to predict rainfall. Nowadays, we are getting red alert, orange alert. Previously, we are telling if it is red alert, it will be so much of sun today, but then slowly the accuracy is also improving. Okay. So weather forecasting is also yet another area where a lot of research and development is happening. In short, what are we doing? We are in a smart planet. And what is computer science behind all of this? Some electronic data capturing through sensors. You get the data in whether in autonomous cars, in smart healthcare, in smart farming, everywhere. You need to get an input. All those who write C programs, what you know, C or C++, whatever the language that you teach, it's not a scanner for a scene. That's a simple variable that you enter. But eventually in a bigger picture is you get the data. The data can be integer, data can be an image, data can be a video, and then you process it. And then people who are good in data structures and algorithms will try to see how fast I can process the data. People who are good in systems, they will think how better I can store them. What are the kind of hardware devices that is being required. And then you make meaningful conclusions out of this. Statistics, and that's the way how you work. So, in short, any computer science related application that we are talking, it all boils down to this. Whether it is an image recognition algorithm, whether it's a sorting program, whether it's computation of average. In short, when you talk to the processor, it all consists of a sequence of operations that you do or a sequence of instructions. An instruction is a basic unit of operation that you do it on a computer. So if you have a software, it consists of multiple instructions you store in memory. So what do? You fetch the instruction. The instructions are combinations of ones and zeros. So I am the processor, that's the memory. I ask him, come. So the instruction will come here. Then I see is ones and zeros. I have no idea what it is. Then I cut into. It has been told me, after the 8 bits you put a cut. Then look at the first 8 bits. If it is 0000011, that means add. If it is 1010, it means subtract. So then I will try to understand what the opcode is, what the operand is, where the data is. So that's called, you decode the instruction, you fetch the operand, you execute. Oh, this means adding R1, R2 and R3. Then I put values in registers, your arithmetic logic unit 2. So any kind of computer program that you do, whether it's a Facebook application or reading news, eventually it boils down to sequence of instructions stored in memory, which your processor is going to fetch, execute, and then looking forward for storing the result. That's the way how it works. Now I am going to talk about something called tiled chip multi-core processors. All what we learn is a computer, inside a computer there is something called a motherboard and there is a processor chip inside. And they were typically consist of unicore processor, dual-core processors and all. In another 3 to 4 years your mobile phone will have hundreds of cores inside it. So this is a typical diagram of a 64-core tiled chip multi-core processors. It's as good as that you have 64 processors inside it, but everything is inside a single chip, and then you can parallelly run 64 applications. Whether the students have a subject called operating systems? Which semester they study? Third semester. So you might have heard about something called context switching. You have a process, you have another process, you have one processor. At any given point of time, only one process will run, and then you temporarily stop it. You switch from one process to another by saving in the stack and then returning back. This is called context switching. Why? One resource for two programs running. So you have to switch between them. Whereas in this scenario, you have 64 processors. And I have 64 different applications can parallelly run. And each of these tiles consists of a core. Core means a processor which can fetch, decode and execute. Your cache memories are there. And then similarly you have 64 such entities. And they all are connected using small wires. So we have a small network inside a chip. That's what's called network on chip. So this is what you see. And if you have to communicate some data, the data goes like this. So from L1 cache to L2 cache, you go and bring data. Everything that is going to happen like that. Then the reply data also comes like this. So I'm going to talk about tiled chip many-core processors called TCMP, where this processing element is your processor, and then you have routers, which are nothing but communication mechanisms through which one processing element contact another. So what are all this processing element consists of? Everything that you learn in a basic computer organization course, or what? You have fetching, decoding, then executing some caches, some control unit, some registers. Everything that you teach in a fundamental computer course. What are there inside a computer? It has some registers, some control unit, so all that what you see is there in processing element. Are there fiction? Yes, we have chips that is available in the market. This processor may cost you 5 lakh, 6 lakh rupees. It may not be there for your laptop, but if you want to do some high-end computations, these are the devices that you do. Even Intel has a processor like this. It's called Intel KNL Knights Landing processor. I'm not going into the detail. So what is network on chip? Imagine this is a 16-core processor. Each of the blue portion is an independent processor, but they are all inside one IC. What do you see? Just like the size of my palm. And then this blue portion consists of processor, and then it caches its smaller memory that you see. And then each processor fetches from this small memory what it is part of. And the green portion is a switch. It's a communication framework which connects all these tiles. So processing units are interconnected by a packet-based network. So a data from one tile to another, if it goes, it will tell, I am coming from 1, I wanted to go to 10, this is my sequence number. Those who have taught computer networks as a subject will know there is a packet and the packet has a header. So similar to that, you have a packet communication, but everything inside a tiny chip, what it's been moving to. So all resources are organized as rectangular tiles on the chip, and the tiles are interconnected by some kind of a routers. So you have seen computer networks, every computer connected to a cable, to a switch, like that. You replace these computers and cables with small cores. So this is a miniature version of a computer network. Everything is inside a small part. The communication is by packets. Now let me talk about something called application specific circuit. So we have a general purpose microprocessor. When it is manufactured, the company person who manufactured don't know whether it is going to a Bharat Mata College student or to a teacher or to a layman. We have no idea. They are general purpose processors. You can run any program on it. You can store any program into its memory and then you fetch and decode. It's general purpose. I can do a Facebook program there. I can stream YouTube video there. It's all simple programs to the hardware and hardware will go and fetch. But there exists another class of devices known as application specific device. It cannot be used for anything else like the way how it is. Okay. So for example, you have a small microprocessor that is there in your automatic washing machine. You cannot run your Facebook there. That is a microprocessor which is meant only for the washing purpose, controlling of the washing machine based upon timer. It will take detergent, it will wash, everything what you see. You have a small microprocessor inside your microwave oven. It may not have all the features. That also has a microprocessor, but it is application specific. For this application, I have dedicatedly built this. You suppose you have fancy cars or very good cars, then car has some kind of a microprocessor there, which will take care of the infotainment system, the sensors. So these are called application specific devices. So when I talk about domain specific accelerators, that means if I ask a conventional microprocessor to perform a division, think of a case, I have to perform a square root operation. So how can I do square root? I will subtract. You know the way how you find square root by repeated subtraction. You do in a loop and then you subtract. So then they take a lot of time. What if I have a small unit who is ustad in square root? So it's a box, you give a number, it will give the square root of that. So how do you can do square root in two ways. One is computation of square root by multiple instructions inside a loop. Or the moment you see square root instruction, you ask it, can you do the square root for me? So I deploy the question to my nearby friend who is called a square root unit. So now what happens if you have a program with a lot of square root operations, if you conventionally do in a general purpose processor, it is slow. Whereas if you have somebody who is there, who is expert in it, you will do that. I'll put up a very simple example. In our college, do you know how salary bills are processed? No. But we have a section in our college, in the office, who are people who are expert in handling of these bills, the salary account and everything. So once the salary related work that is been coming, the principal deploys that file to a person. So the person sitting in the office is called a domain specific accelerator because for that task, he can do it. I can also do it. I may take a big sheet and then find out everything. Let's say there is a conducting of a national workshop or something like that, it's been given. Anybody else can do. But if there is a senior person in the department who can do it, the principal can deploy the task. So he is a co-processor to the main processor in carrying out this activity. So this is called domain specific accelerator. So think of a case, you have a matrix multiplication. Do you know how matrix multiplication is done? Those who are from computer science programming background, you know, you have a for loop of I and j. Inside there is one more for loop of k, and that was the most complex program that we studied. And first we have no idea how this matrix multiplication works. You by heart and slowly over the years you understand. But you see how complex is the code. What if I get a unit which is specialized in matrix multiplication? The moment I say A equal to B into C, I deploy to him A and B, I dump to him, he will perform multiplication and give back. This is yet another accelerator. So if you have a program with a lot of matrix multiplication, then this accelerator will help you. Did you understand what is the concept of accelerator? So domain specific accelerator, graphics processing unit, neural network processors, everything they have some dedicated units which will perform help in certain class of instructions. Now let me tell you what is the advantage. Consider the case of an add instruction. You have to perform an add. In a general purpose computer, you store the add instruction in memory, you have to fetch it, try to understand it is add. Yeah, it's adding of R1 and R2, then I bring R1 and R2, put up inside your ALU, then tell ALU, come on, add it. Then you will produce the result. Okay? So you have to fetch, go to the cache and bring, then you bring register. So the blue portion what you see, these are all the preparations for adding. The real adding inside your adder is only this orange portion that you see, which will consume overall less than 1 picojoule. Are you able to understand what I am telling? See, I will simply tell for ladies to understand it better. I wanted to eat, let's say, a chicken curry. So the eating is the real task. But do you know how much effort you all put in making me eat that curry? Cooking, getting all the ingredients ready. You got to know? There are not many activities that has been involved prior to that. So this is also available in an instruction. I have a lot of overhead if I use a general purpose processor in carrying out a task, because the processor can do multiple tasks. So first I have to understand what is a task. I cannot store the instruction inside processor. It is in memory. Bring it, understand it, do it. So the real doing. So this is something called an application specific integrated circuit, exclusively adding. So there is a guy, he will do only adding. So there is no question of fetching and trying to understand what it is. Give the instruction, he will add. So there is less of drama before there. Whereas in this case, lot of drama is there. But if my purpose is only adding, then this is not required, right? I can get it done with this. Okay? So slowly I am trying to link it to the one. So there are different domains in which this domain, different areas in which domain-specific accelerators make sense, be it in graphics, in deep learning, in simulation, in image processing, security and all. I'll come and talk about it a bit later. So when you talk about computer systems, it can be CPUs, general microprocessors which can do anything, what you see in your laptop, to application-specific integrated circuits. See, you are using biometric punching here. So that is an ASIC. It is meant only for getting a thumb, verifying, sending that to the central database and then verifying that. There is a small processor there. It is an application-specific integrated circuit. But it cannot run WhatsApp. It cannot play YouTube. Okay, highly customized. Whereas this can also be done connected to a computer has a biometric thing where the computer can directly run it. So we can have CPUs. So as you move towards the left side, it's more flexible. Flexible means you can run any program. When you go to right side, less flexibility. You run only that particular task. So that's all about that. Now let me come to neural networks. We have neurons that we have learned in biology classes. There is a neuron, some input is there, the neuron will process something and then it will give to the next neuron. Each neuron will excite the next one. Let us come to artificial neurons. What an artificial neuron does is, it is a box. The box has many inputs. We call them X1, X2, X3 like that. Now what this box is doing? This box will do multiplication and addition. So, if these 3 people are connected to me, he will give me a value, sir will give another value, madam will give another value. All what I do is, his value into something. I have to fuse all these 3. Okay? Now think of a case, he is my close friend. And now he is telling, John, there is a big block in Edapalli Toll. She is telling, no, there is not much at all that is there. And he is telling something else. Now what I am doing is, I give more importance to what he is saying. I have to process all these 3 inputs and I have to take a decision. How will I reach Edapalli Toll? This route. So all of the 3 of you are giving some input. So what I do, your input into 0.1, your input into 0.05 and your input into 0.85. I am giving more importance to his input in taking my decision. Did you get that? So this is called weight. There is an input and to each input I have to associate a weight. So input into weight is what I do. X0 into W0. If W0 is 0, whatever you tell, I will not process it. It's 0. If it is 0.1 means, I give you little importance. So what happening in each of our family also is like a neuron what you do. You get a lot of inputs. Some of the inputs you give more weightage. You get a lot of advices daily, right? Do this, do that and all. Some inputs are like noise. What is the noise means? Weight equal to 0. Whatever your mother tells, weight is equal to 0. Friends are telling something else. Yeah, weight is equal to 0.9. So this is what we do is lot of inputs you get, you multiply with the appropriate weight. And the last assumption. Input. That is called bias. Okay, this B. So what you do? Wi into Xi. Each of them. At the end of all this, you put a B. Now you see your value is above 0.5. Then I will take this. This is yes. If it is less than 0.5, this is no. Can you understand what a circuit is now? So now how will you write a small C program code for it? You have X1, X2, X3 are inputs, W1, W2, W3 are weights. You perform the multiplication of them, sum it, and then you add a value called B. If the output is above a threshold, yes. If the output is below a threshold, no. This is a simple neuron. Okay. I am not from ANML. I started this only 2 months before. Now, I connect lot many of these neurons put together. So now the output of one neuron is connected to another neuron. Like that I can create a collection of neurons. This is called neural network. Is it simple to understand? Now you just imagine, I am a box, I will get inputs and weights, I process, I put it to the next guy, he will again process. Like that, there is a collection of neurons that has been arranged and linked between each other. So we have an input layer, we have an output layer, we have some hidden layers. Sometimes the number of hidden layers are also more. Now if you're talking about a neural network, a deep neural network. Deep means there are a lot of layers in between. The number of layers are very much. That's called a deep neural network. Okay? Now, these are the kind of devices which will tell you in solving some of our classical problems. Now look at this picture. You have a car. It is a Volvo car. Okay? Now, my computer science problem is, given this car as an input to a program, this program should tell it is a Volvo car. Fantastic, right? Is it challenging enough? To my program, I will upload an image. The program will tell it is Volvo or it is not Volvo. Okay? I will put it in a different way. I am giving an image of a person. Sir is looking, I am taking his picture and then putting it. Now, my program should tell, is he smiling or not? Tomorrow I will give somebody else's picture. I can put madam's picture. But the program should tell it is smiling. So it is a smile recognition program. Did you understand what I am telling? Huh? Is it very difficult to grasp? No. Now, how do I teach the machine? First I will tell, this is John sir's photo. And what happened? The photo is cut into pieces. Okay? I divide this picture into rows and columns and take each one out. These are x1, x2, x3, x4. Up to x100. Now I give it to you. Can you see what is this? This is my neural network. I put some random weights initially. And I will tell the system, ultimately at the end, system should tell if the value of the output should be more than 0.5. So when his smiling face is given, my output should be above 0.5. If it is not a smiling face, then output should be less than 0.5. So what I am telling initially, I am uploading a picture and I calculate with some random input is given, some weights are already there. System is telling, oh, this is only 0.3. Then what will I tell? I wanted to get 0.5. So what will I do? I will adjust my weights. Please give me one more chance. Again the picture is given. Now which is 0.45. I don't know, no. This should not be 0.45. It should be above 0.5 because it's a smiling picture, right? So they will keep on adjusting the weight. Somehow for his smiling face, system tells, oh my God, I got 0.5. Now suddenly I am giving madam's picture as input. Now what is the task with the program? This input also should tell it is smiling. Yeah, so somehow they will adjust again weights. Now I am telling sir's picture also should give 0.5. Madam's picture also should get more than 0.5. Oh my God. Then they will again adjust the weight. So these two smiling faces system told. Now she is showing a sad face. Now I should input that should give less than 0.5. This process is called training. Okay? So what will I do? I will show hundreds of images. I know as a user these are all smiling or not smiling. I want my system to understand it correctly. Okay? So I train the system. In a more simple way, you buy a new dog. Okay? And the dog doesn't know who is your master. I have my wife and 2 daughters. So I will tell, I am the boss, I am giving you food. So the dog understands, okay, this guy is my friend. This is my wife. This is my friend. These are my daughters. So the dog understands these 4 members are his family. So I should respond when they come to me. I should respond in a loving way. So suddenly he is coming to my home. Then dog should react differently. No? What was I trying to teach the dog? Teaching who are my family members. That is called dog learns from my input. Okay? It's called dog learning. What am I doing? Training the dog, telling that these 4 people are the important ones. So now any picture of we 4 people, the dog has to smile. Anybody else outside we 4 as a family member should go, dog should treat differently. Replace dog with a machine, that is called machine learning. You train the system and later after that, system will give you corresponding output. So this is what a deep neural network does. So we have fully connected networks where each node is connected to every other node. So the purpose of this neural network is, I can have 2 types of system. One is called a recognition system. Recognition system means given an input, system will tell yes or no. So I am giving a Volvo car's input, system will tell yes, this is Volvo, no, this is not Volvo. So this is called decision problem. Yes or no. The second class, which is more complex, is given a car, it should tell, this is Volvo, this picture is Maruti, this picture is Hyundai. Then it is a classification problem. I am not telling yes or no. Given an input, I am telling you, okay, this is a human being, this is a horse, this is a monkey. Then it's more complex to do. So we have neural networks which will do that, which is outside the scope of my talk. What will I do? So we have 2 phases generally. One is called the training phase, what I told, like telling the dog what all things to be done. Second one is called inference. So training is a process by which I determine the weights and the bias, and inference is a process. So I have a neural network, I give the input, I keep on correcting unless I fix the network. A trained neural network. The second classification is now I give a cat. The trained neural network should tell, okay, I am telling 80% it looks like a cat, 20% it looks like a horse, 5% it looks like that. I can tell with confidence, cat, dog, car, house, whatever it is. System will tell. So 80% system is telling it's good or not. When you upload a picture in Facebook, is it telling tag your friend, automatically the friend's name is coming? The background is this. Given an image, it is able to search it in all in pictures, and then system itself is telling, yeah, this is so and so. Do you want it to tag? So that's the way how things have been learned. Now what happens in all these cases, every neural network that you are talking, it consists of hundreds of inputs, hundreds of weights, hundreds of layers. And what I have to do? Matrix multiplication. I take this into that. So it takes a lot of data stored in memory to be brought, multiplied and put it back. So when I use a conventional system with the cores, data and all, most of the system time what I am doing is, I am storing my inputs and weights, I bring all the inputs into the processor, perform A to B and asking him to go back. So this movement will take a lot of time. Okay, so the conventional computers are not good for machine learning applications because for a small multiplication and addition, which the memory cannot do, it can be only done by an adder. I bring lot of data and then so lot of data movements, lot of peripheral activities than the real activity. Sometimes you do know, when you cook certain food, everybody eats in 10 minutes. 2 hours of hard work is finished in 10 minutes. Okay, so essentially you wanted to cut it down. That's exactly what we are trying to do. So what are the limitations of a general processor-based design? We have a lot of movement from hard disk to DRAM, to the caches to the CPU. Most of the system is dedicated to storing and moving data. So what you have to do in new ML related level. Let the processor move to that side. Then can your memory have a small adder? Then it's good. No, you can go and do. Don't do any complex operation. A to B, Xi into Wi, I can do it as close as possible. So altogether in the last 4 or 5 years, we understood that doing any AI ML application involves a lot of neurons, connected layers and inputs and weights getting multiplied. Should not be done in the conventional microprocessor. You can do it, but it takes a lot of time. I asked this image, is it John? He will tell you go for a coffee and come back. By the time I will tell you it is John or not. Lot of data. Or else the moment it has to tell. So future we want AIs. Now some of you might have traveled in aircrafts that you know our digital public infrastructure. There is nothing that you should show that this is my boarding pass, my ticket. You simply go, your face is recognized or connected to the ticket. So everywhere, wherever I go, the gates will automatically open. Another 3 years, all the railway station also, it's like that. There will be a name that is there. Your face is linked to the Aadhaar. Your biometric is linked. The moment you wanted to travel, you upload the ticket into DigiYatra and then you enter into the railway station. Your ticket is recognized. So your ID, your face is connected to the ticket. There is no other proofing required. All what you want is an AI camera. But this camera works like this. No, from millions, crores of Indians, if you enter from Alwar railway station, out of this crore, you have to be recognized quickly. Yeah, you are so and so. You are traveling from Alwar to Calicut on this train. You have to book the train ticket and then it is connected to DigiYatra. No other country in this world can do this. India is the only country where such kind of facilities are there. I have traveled to so many countries and many of the transportation system in Western Europe is pathetic. The way how Indian airports handle this huge volume of data is great. So last 4 or 5 years, digital public infrastructure has grown a lot. And then if you wanted to get benefit of this, you should be aware of the real life problems what currently engineers or computer science people are working and do projects or assignment closely connected to that, put up in your CV and then you apply for jobs. It's very easy. At least we want next 5 to 10 years, thousands of people who have some idea of AI processors. So how do you handle data? Either by writing good, if you are good in algorithms and data structures, you write good algorithms, by intelligent algorithms. If you are good in operating system networks and computer architecture, develop good hardware which can make use of your conventional algorithm. So one way is same hardware, better algorithm. Second one is same algorithm, better hardware. Both will give you another. Third one is co-design. Improved hardware and improved algorithm put together. So people feel software is good, hardware is good. It's the same question. In a building construction, is mason important or carpenter important? All are equally important. They have to work joint hands and then work it. So in data-centric architecture, try to see process data where it resides. Processing in and near memory structures. You should come up with a new conventional methodology has to change. Low latency, low energy is important. Do you ever buy a mobile phone so that in another 3 hours the battery gets drained? At least you want morning onwards till evening, I need to have a mobile phone charging. So you can come up with fantastic architectures and algorithm, but what if in 2 hours your battery gets drained to zero? You don't want it. You want the solutions to be cost effective, consuming less energy, less area, less power. I cannot have a device big as like air conditioned blower. It should be handled in the pocket. Less power, less radiation. So that's the challenge. Low latency and low energy memory, low latency memory, low cost devices and intelligent data management. So we talked about deep neural network. There are a lot of layers inside it. Some convolution layers are there, like what I told. And what they basically do, what is convolution? Xi into Wi plus you have a B, the activation bias that you have to do. So this is the way how convolution generally happens. So convolutions means 90% of the time convolution is matrix multiplication is your task. And then you have a huge amount of data. Now can you imagine what you do here is, this is your matrix. Let's say your image is there, I put it as a matrix. Now I have a small kernel matrix which I multiply with each of them. That's what you see. So the value in the blue multiplied with the value in the front mesh, multiply it together and then you produce. So what you see is a huge bulk of multiplication and addition. So you require a lot of MAC units. MAC stands for multiplication, addition and accumulating values. So you require, what is your AI engine? Google's AI engine means it is a collection of multiplier and adder units. Now this xi value and yi value that I pick from memory has to be dumped to all of you. Take your x, take your w, multiply, give it back. Now I have to give it to hundreds of them. They all will perform multiplication, put it back and they add by bias, see it is above 0.5 or not. If yes, I will tell my operating system, yes, you can show this guy is John. This guy is not John. That's essentially the idea of. So, in short, this is what you do. You multiply all these to get one value, yes or no. Now think, how am I producing? This is one layer, okay, one layer of the convolution layer. I multiply all this much operation I do to get a value this. You look at the figure, okay? This many operations I do, perform an activation function, and then you get 1 or 0. It's 1 bit. Can you see this? Now, what I do is, I keep on changing the front layer. And each one will produce by each of the data. Okay? Continue further, I go to the next row. Are you able to visualize what happens in this forward diagram? This is my input to the next layer. Now this has to be processed again. There are 70 to 80 to 90 layers that is been there. Have you seen Alexa, this device, where you can tell Google, you can tell using voice, right? They have to recognize your voice. Ultimately in background this is running. From your voice they have to understand the meaning, the grammar. It has to be converted to some database query, search in the entire web, bring back the result. And telling, I want Yeshuda's song. It's a simple words. Some sound it is coming, it has to understand Yeshudas is a Malayalam song, singer, and then you go and get it from database and display the result. Now I am telling, I want images of Volvo car. You tell it in through mic, you will get Volvo car pictures. So that QUIC is the response of the hardware engine that you have. So in short, what you can see, I talked about multi-core processors. You have these processing elements which will carry this data. I produce the data, it is passed through the network and then comes. There is no electronics inside, it's fully computer science. My background is fully computer science. This is what our students do in the laboratory. And there are a lot of students who are doing MSc plus MCA, come to our lab, spend 1 or 2 months, do this, write papers in good journals, and they are being picked up by companies for a salary minimum of 1 lakh per month. Students from normal colleges, from Kerala, from Coimbatore, from Nagarjunasagar, many people come. So all this is, hope you know what this is now. It's a multi-core processor. All these boxes are adder units. The adder plus the back units that is there. And then you, from the memory, what you have to bring? The inputs and the weights has to come. So I will bring them. Now see the process. I am quickly completing. From the memory, I bring the data here. Then from there what happens? These are the units which will do the task for me. And then I have to send it to all these units. These units will perform the activity there. What will they do? They do the convolution operation of xi into yi. And then they will return back the result. And then the result is stored as an output. Now you repeat for next layer. Then can you understand? Even if you talk about very fantastic, fascinating things like AI or ML, ultimately you require a computing device. So there is a lot of fascination that people think only AI and ML is important. Ultimately you want a device that will run this show. If the device is general purpose, it will not serve this. But if the device is very much specific, see there is a difference. You can also stitch a dress. But a tailor also can stitch a dress. You can also do it. You take more time, you have to look into that, right? And sometimes you make new recipes at home. How do you do? Look at Google, okay, you have to take onion, you have to take curry leaves, everything then you do. But if somebody who is an expert in cooking that item, they don't want anything. So we want dedicated hardware to do. And we were spending a lot of money in importing this consumer electronics gadget. Do you experience shortage of plug points in your home? But 10 years before that was not the case, right? Every year you buy one more electronic gadget. And from where are we importing? We are importing all these gadgets from outside. First time in the history of independent India, Ministry of Electronics and IT which governs all computer science frameworks curriculum, is being headed by 2 electronics engineers. One is Ashwini Vaishnav, who is our Minister of Electronics and IT, who might have landed in Trivandrum for inauguration of Vande Bharat train. BTech Electronics Gold Medalist. He is the Electronics Minister. Second one is Rajiv Chandrasekhar. He is from Thrissur. He is one of the director of Asianet Channel. But the people don't know. He is an electrical engineer from Manipal Institute. He is an MBA from Harvard. He is our electronics engineer who is a minister. So these 2 ministers, after 75 years, we got highly learned people sitting in Ministry of Electronics and IT. Now, next cabinet, whichever it is, coming by 2024 elections, first time, first country in the world to have Ministry of Artificial Intelligence. The groundwork is being done. Can you imagine the rate at which it grows? And who has to contribute in this growth? We have to contribute in this growth. How do we pick up the skills? The so-called Kerala with the highest literacy rate is contributing minimal to the higher education scenario of the country. Because all what we want is 30,000 rupee job and we are happy with it. But people from other states who are much poorer than us will study further, either for a master's program or a PhD program, and they land up into these key crucial positions. And we always wanted to migrate to other countries to be at the slaves. So once one war comes, again we have to send Vande Bharat flight to bring you back. There are plenty of avenues in our country, but somehow our media is portraying Kerala in a wrong way. We are being bombarded with news which are a lot